record this. Hi folks, would you please turn on your cameras? Welcome back after a week off. I trust you've had a chance to rejuvenate a little bit, maybe remember what it's like to sleep in and not feel the weight of the world hanging on your shoulders every day when you wake up. I hope you felt that for a bit, and I'm sorry that we're back to the stresses and strains of what this is, but we'll work through this together. We've only got a few more months. We will get there. We had a meeting this morning with the teachers and the administration. It sounds as if they're pushing to get hybrid learning started on Tuesday of next week, 1 week from tomorrow. So we don't know what's going on with that. It honestly feels to me like there's an awful lot of insecurity over what it's going to look like. But we're trying to find out what it looks like. So for example, I am in my office right now, in my classroom, first time in a year. So you guys haven't yet seen the classroom. Give you a quick little tour here. That's upside down. That's going to make it a little confusing. So there's the back door leading out to campus. Here are the desks, nicely spaced. A couple of different monitors for us to use. The whiteboards we'll use, TV, and here's my command station that I just finished setting up. So we are figuring out how to make this thing work. And there will be some things that are challenging for sure, for you and for us. And I commit to you guys some continuity. In other words, you can expect that I will continue to live broadcast instructions that fill in, number 2, the scaffolded notes. I'll continue with those. And number 3, I'll record them as I'm recording this one to post for you. And number 4, I'll post the answer keys for you. So that's my commitment to continuity. I don't know what the rest is going to look like. I don't know how hybrid is going to be better or if it will be worse and what restrictions there are and how much time we'll have, but we'll do the best we can with that. Are there any questions? Do I plan on keeping the Moodle tests? Probably. There may be a reason to have a graded in-person activity on paper as well. But I generally like the Moodle tests. I generally feel like they're authentic in what they are. Any other questions?
While some people are in classroom, are you going to be also on Zoom? So the people who are like at home are in the same class as the people in hybrid class?
We are being required to have simulcast of some sort. So my expectation is that I'll be doing this like I'm doing today. This is my first chance doing it for my classroom. And it'll be projected on the screens for people. They'll be able to both see my face as well as the document camera, just as you do from home. I don't expect there'll be another survey about if you want to go back or not. If you have changed your mind about that, you should contact one of the administrators. I don't know which one, maybe Connor Snow or Kaki McLaughlin or Karen Hatton or JC Farr. Okay, I would like to get rolling here because it's going to take most of the class to get us through this worksheet today. There's the worksheet in case you haven't already pulled it down from Canvas. I'm going to change over to my document camera now. And again, this document camera is new for me. It's not the same one I've been using for the year. So let me make sure that you guys can see it. Is that clear? Please give me something in the chat. 5, yes, that's clear, I'm good. 3, it's okay, I can make do with it. 1, I can't even read that thing. Okay, good. All right, let me change a couple of settings here. Okay, so what we're working into is something called similar polygons. And we'll get to that in a second, but in order to get there, we have to have some foundational knowledge. And the first piece is what a ratio is. I know this looks like patio, but this is supposed to be a ratio. And what a ratio is a comparison That's not going to work, is it? Hold on, let me adjust this a little bit that way. Of two or more quantities. It's a comparison of two things. We can represent ratios a few different ways. You've probably seen them represented as A colon B. That's traditional ratio format. You could also have it as a fraction, A over B. Or you could use the word to in between, A to B. And regardless of which of those three formats you're using, ratios can be simplified. And this is intuitive for fractions. Of course, you can simplify a fraction, but you wouldn't think about simplifying these. But yes, you can do that as well, simplified or reduced. So for example, we've got 40 trumpets, 39 clarinets, 24 violins, 51 flutes, 16 trombones. It's a really big band. What's the ratio of trumpets to violins? Okay, well, we've got 40 trumpets to 24 violins. So I'm going to start with the ratio colon 40 to 24, and that is a valid ratio. It compares trumpets to violins, but it says to write the ratio in simplest form. So I have to reduce this, just like it was a fraction. I'd see what number goes into each of these. I know 2 goes into both of them, but I can probably go bigger. 4 goes into both of them. 6 doesn't go into that. 8 goes into both of them. So 8 times 5 is 40. 5 is a prime number, so I know it's not going to go any further. So if I take an 8 out of both of these, I'll get another ratio that's equivalent. It's the ratio in simplest form. So then let's do trombones to trumpets. There are 16 trombones. I'm going to do as a fraction this time. And there are 40 trumpets. And what is that going to reduce to? Well, 4 goes into those. 8 goes in again, doesn't it? 4 and 5. Yep. 8 goes in again. So this time it'll be 4 to 5. Any questions on reducing ratios or simplifying ratios?
Quick question. I think 40 goes into 5, or 5 goes into 48 times, but shouldn't it be a 2 instead of a 4?
Ah, very good. You're exactly right. Thank you. Good catch, Joe. That's exactly right. We divided both by 8, so it should be 2/5, not 4/5. And I see a question here. I was caught in the chat for a second. Are we allowed to use our own computers at school or only the Chromebooks? Maybe someone else has a different answer. I would say you do what you want to do. If you like using the Chromebooks because it's consistent and easily accessible, that's great. I am currently using my own personal computer right now, and the internet picks it up and everything else works fine. So I would guess you'd be able to bring your own. Okay, I'm going to leave questions 2 and 4 for you to fill out on your own, including the reduction of them or simplification of them. Next, there's a topic called extended ratios. And this is just a refinement or an extension on it, which has to do with a comparison of more than 2 quantities. In other words, when you start looking at 3 or 4 items being compared in a ratio relationship, there are a couple things that change. Extended ratios are really only written in the colon format, A to B to C. You wouldn't expect to see a fraction with 3 tiers. That just doesn't exist. And what this is useful for is solving problems. So we'll start with a problem that really could be just a ratio problem because it's only got 2 components. But off to the left here, I've written the formula of sorts. To solve these things, you need to choose the sum of the weighted parts, and that's equal to the whole. So in this case, we have a ratio of two complementary numbers, complementary angles, and the ratio is 3 to 7. So what does complementary mean?
Add up to 90 degrees.
Very good. Adds up to 90 degrees. So that means our total is going to be 90. In other words, the whole must be 90 degrees if they add up to 90. But the components we've got are 3 to 7 in that ratio. But we don't know if it's 3 and 7 or 6 and 14 or 9 and 21 or 15 and 35, right? We don't know what it is, but we know that whatever the thing multiplying times 1 will be the same as the thing multiplying times the other. So we'll express this as 3x plus 7x. In other words, they're both being weighted by some number x, and that will scale it into matching together to make 90 total. So in this case, 3x plus 7x is 10x equals 90, which means x equals 9. And if I plug it back in, I'd get measure of angle 1 equals 3 times 9 equals 27. Measure of angle 2 equals 7 times 9 equals 63 degrees. And those are our two angles that are in a 3 to 7 ratio and complementary. Okay, I'm going to move down to number 8 now. The ratio of the measures of the angles in a triangle is 11 to 2 to 5. Find the measures of the largest angle. Well, I see my ratio parts, so I know it's going to be 11x plus 2x plus 5x, but what's my total here? Didn't give me like complementary here.
180 because triangles add to 180.
Very good. It says the angles in a triangle, and you should know that the angles in a triangle always add up to 180. So the whole here is 180. So this is going to be 13 plus 5 is 18x equals 180. So x equals 10. And it asks for the largest angle. Well, if my ratios are 11 to 2 to 5, the 11 has to be the largest angle. So 11 times this 10 equals 110 degrees. Okay, would you please put an answer in the chat to this question? How do you feel about simplifying ratios and solving problems? 5, this seems very fundamental. I think I can handle this. 3, it's a good reminder. I've forgotten some of this stuff, but I think I can get there. 1, this stuff confuses me. Okay, good scores. Any questions on what we've done so far? Let's move on to page 2, please. At the top is just 2 more of those same types of problems. Let's try to do this one yourselves, please. Everyone try number 9 right now with me. Go. I'm going to go back for a second here because I wasn't recording that last little piece. So an equation that states 2 ratios are equal is called a proportion. And a proportion is written as the 2 ratios set equal, like A over B equals C over D. And once we get a valid proportion, we can do things to it that are valid, like I could add a 5 to this side and a 5 to this side, just algebraic rules. But there's a shortcut called the cross product property. And what it says is if you multiply the top on the left times the bottom on the right, and that's equal to the top on the right times the bottom on the left. In other words, AD equals BC. And of course, because of symmetric property, you could switch that around and say BC equals AD, right? So we can use that to then solve number 11. This is a valid proportion. It's given to us as a ratio equals a ratio. Therefore, I can do my cross products. I can say 2 times x equals 4 times 7. So if 2x equals 28, then x equals 14. Easy peasy. We can notch up the level of difficulty a little bit. Number 13 now has a binomial in one of the terms, but it's still the same. I'm going to multiply 19 times x minus 1. I just have to remember to keep the x minus 1 in parentheses because it's that whole term being multiplied by the 19. So that when I distribute it, I distribute it across both parts. 19x minus 19 equals 78. And then I'll add 19 to both sides. And this one's not going to come out pretty. Or maybe you're a true mathematician at heart and you see the beauty in that. There's no way to reduce that. 19 is a prime number and it doesn't divide into 97 evenly. So don't try to turn it into a rounded decimal where you're losing precision. Leave it like this. This is the most precise number you can give. If you can reduce it, you should. Let's go down and do 17. Same idea. We're going to cross multiply. So 18 times quantity x minus 20 equals 3 times quantity x minus 11. Distribute. 18x minus 360 equals 3x minus 33. I'll bring the 3x over here, so 15x. I'll add 360 to the other side equals 327. So x equals 327 over 15. It's not going to go in evenly because this one doesn't end in 0 or 5, but I can reduce it because I know that 3 and 27 are both multiples of 3. Therefore, this whole thing is a multiple of 3, and 15 is a multiple of 3, so I can get 109 out of 5. And that's as far as I can really take it. Could you write 21 and 4/5? Sure. But this is a good, precise answer, and I'm okay with improper fractions. How do you feel about these? In the chat, please. Solving proportions. 5, this is my jam. 3, I can do this. This is algebra. 1, this has always been hard for me. Okay, good. Pretty good scores. So we're going to notch it up one more level, of course, because this is the way we do it. Anybody see what's going to happen when we do this one? We're going to have 2 x terms multiplied together, aren't we? So I'm going to have x minus 1 times x plus 5 equals 5 times 27. And this is now a binomial times a binomial. And this requires the FOIL method or the distribution so that we take x times x is x squared. And then we can do the outer terms, so plus 5x. We can do the inner terms, minus 1x. And then the last terms. And that completes the distribution of each of the binomials across the other. 5 times 27 is 135. And now I'm going to combine like terms because I got some x's in here. So x squared plus 4x minus 5 equals 135. And This is where people forget. Because on the previous ones, we would move the 5 over to the right, isolating the constants, getting them alone and getting the x's alone on the left. But the problem is we've got an x squared and an x. This is a quadratic. And so because it's a quadratic, instead of moving the 5 over here, we want to move the 135 over here. So we're going to subtract 135 from both sides, giving us x squared plus 4x minus 140 equals 0. And the key here is that it equals 0. Our goal has to be to achieve a binomial times a binomial equals 0. Then we can apply the zero product property. So that's our goal. So the way we're going to get there is we're going to factor this. Usually when we factor this, we put a negative 140 on top and a plus 4 on the bottom, and we look for two numbers that multiply to make 140, negative, and add to make a 4. So because it's a negative on the top, I know that one's going to be negative and one's going to be positive. And that means when I add them together, it's really like subtracting the numbers, and their difference is a 4. So 14 and 10 jump out at me. That's a difference of 4. And in order to make a positive 4, I need the 14 to be positive, while the 10 is negative. So that's my expression. Now, depending on what type of problem you're doing, in this particular case, you could actually just pump these in here and say it's x minus 10 and x plus 14. But if this were a more challenging one, like with a lead coefficient of 2, as we're going to see in the next one that you're going to do as your homework, you'd want to set this up as factor by grouping. In other words, you take this 4x and you split it out into these two. Minus 10x plus 14x minus 140 equals 0. And then you see what factors out of these first two. In this case, there's an x, which factors into x minus 10. And you see what's true into these two. There's a 14 in both of them, leaving x minus 10. And then you can say now what's true about this term and true about this term that you can factor out. Well, they've both got an x minus 10. So I pull that out, and what's left is x plus 14. Once you get to this factored form, you're going to apply the zero product property. Either x minus 10 equals 0, which means x equals 10, or x plus 14 equals 0, in which case x equals negative 14. Those are our two answers. Any questions? This is usually the hardest part for people. Please give me some feedback. How do you feel about solving proportions with quadratics in them? 5, I can still do this. 3, I can do it, but there are some challenges to it. It's a little rusty for me. I'm going to have to remember it. 1, quadratics were always my Achilles heel. I need to learn that. Okay. Last page. So this is what we're going after now. The reason we're learning this is for chapter 8, which is the similar polygons. And it's not like, a Ford truck and a Chevy truck are similar vehicles. You could argue about that all day, but it doesn't mean that similar. Similar in geometry means they have the same shape, but different size. So I could have two squares, one's huge and one's little. And the fact that they're squares means that they're similar because all the corresponding angles are congruent while all the corresponding sides are proportional. That's why we had to get into ratios and proportions. In other words, what that means is if you take the ratio of any two sides, like 8 to 12, 10 to 15, 14 to 21, the ratio of corresponding sides is consistent, and it's called the scale factor. Because really similar shapes are dilations of each other. So we're using that term scale factor that we used before. Interesting tidbit, if polygons are similar, then their perimeters are also similar, are also proportional. And I'm sorry, guys, that is the end of our class. I'm going to finish up here, though, because we're recording. If you want to stay for about 3 more minutes, we can finish it up. If you need to leave, you may leave. So we're going to talk about the scale factor of ABC to DEF. What that means, as we just said here, is it's the ratio of corresponding sides. So if I take, for instance, this side, I'm just randomly picking side AB as its length 8. I need to find the matching one. There's 3 ways I can find it. One is by the markings. It's marked between the 1 and the 2 angles. So this 12 is between the 1 and the 2 angles. Secondly, we should be given our statements in such a way that AB, the one we're looking at, is positioned in the same location as DE, 12, the one we're looking at. And then at least for triangles, you would know that if these 2 things are similar, then the scale factor would mean that the smallest side in this one, 8, has to match with the smallest side in this one. And the mediumest side has to match with the mediumest, and the biggest side has to match with the biggest. So 8 would match with 12. And then again, remember that we can reduce a ratio. So if we're given this scale factor, we could reduce this and say 4 goes into both of those. And that means we could say that the scale factor is 2 to 3. One of the key pieces here to recognize is that scale factor is important to recognize left and right. Like what's on the left here reflects the first one given, triangle ABC. And what's on the right, DEF, is on the right. So if the question had been changed to what is the scale factor of DEF to ABC, then I could still pick 12 and 8, or I can pick 15 and 10, or I can pick 21 and 14. It doesn't really matter. But now I'm putting the bigger one first. And of course, my scale factor will look backwards because now I'm going from DEF to ABC. And then not surprisingly, because they're asking us about the perimeter, 10, 20, 30, 48, we're going from DEF, which has a perimeter of 48, to 18, 32, 32. And if we reduce that by dividing both by 16, we should get the same scale factor for the perimeter DEF to ABC as a length of sides DEF to ABC. Last piece. Once we establish that 2 shapes are similar, we can write a similarity statement, which ties them together. So for example, we can say that I'm going to call this triangle CAB. I chose to go this way to name the first one. First one's free. But once I do that, I now have to match it up. So what shape would that be similar to? What do I name this one?
FDE.
Very good. Starting on the 3, working my way back through the 1, and then up to the 2. So FDE. And that tells me, just as it did for our congruence world, all the relationships between these. Angle C will be the same as angle F. Angle A will be the same as angle D. Angle B will be the same as E. And AB and DE, they're not going to be congruent. They're going to be proportional, but those are the corresponding components. Notice that the comparison between these 2 triangles is not a congruent symbol. It's just that little squiggly from the top of it, meaning similar. But if we're given that statement, the congruence or similarity statement, we know everything. So angle K matches up with angle M here. Since these triangles are similar, we expect those angles to be congruent, such that angle K is congruent to angle M. And angle L will be congruent to angle N. And then my last one would be angle J would be congruent to angle P. Because in similar triangles, all the corresponding angles are congruent. But for sides, it's different, right? For sides, what we're expecting is they're proportional. They're in the same scale factor. So if we look at JK, let me mark these as 3 marks. JK is the first 2 letters here. And so the first 2 letters in its corresponding similarity statement would mean that JK and PM are in some ratio. I don't know what it is, but whatever that ratio is, it's going to be the same as when I compare MN with KL. Any 2 pairs of corresponding sides will be in the same ratio or proportional. So the third side, we've done KL, we've done JK, so JL is the third side, and that would mean PN.